I will just give you a short presentation on what we are doing in the GINO program, some example from what we have been done. GINO stands for Grid Inferences on Nuclear Power Plants in operation. It is sponsored then by the nuclear portfolio, so it's of course the companies owning nuclear power, so Vattenfall, Uniper, TVO, Fortum. Then we have some small Skelleftekraft and Karlstad Energi. And they are in all the programs we have, so they are also the ones who have sponsored this event and the lunch and so for you. But then in GINO we have additional members from the Swedish Radiation Authority and the Svenska Kraftnät, which is our TSO then for the grid. So the vision there is then that the external grid should not cause any unforeseen impact or on systems and functions or causing interruption in any plant state. They have a little bit more budget in their program because of this external financing, so they have about 2 million per year to spend. Otherwise, it's a bit similar setup that we in the steering group from input from your on the power plant discusses what do we need to develop, and then we facilitate the research by contracting researchers from universities or consultants also there. Since it's a bit bigger, we have some cooperation with the large Finnish R&D project Saphir. And also, since this is sort of the interact to both how the grid works, but also then we come into also how does the energy market work as a whole, with all different type of business model for frequency regulation and things like that, frequency control. We have a lot more couplings to other programs within Energiforsk, of course. And then I can say some shortly on then the type of things that we have in the focus areas for the research. It's a lot of system interaction. So there we have had many projects the last years where we sort of try to understand what is happening with the system. Like, as you know, for example, in Sweden, we have gone from having 50% nuclear and 50% hydro, but we have decreased nuclear to about 30%, and we have a lot more wind in the system. So we get a totally different dynamics. And what does this mean to our power plants? And also to sort of what can this lead to different type of events that we can see that, because for today, for example, this HVDC link power links are sort of the things that are dimensioning in the system. So that also makes consequences when sort of design and plan the operation. And of course, in system, finally, we are also looking, and we will publish another report on that, is sort of what system services could be then provide. Because, for example, on the continent now, unfortunately, Germany are closing their power plants, but since they had much more wind, they have also looked more on the flexible operation. So we have tried to learn lessons from that to see if that's the way we are going in Sweden, what type of adaptations would we have to do that. So when you know the system interactions and how either to provide services or to improve the resilience for the nuclear power plants, we come into sort of the design principles. How do we design the power plants in the best way to handle these type of things that can happen? And then when you have design principles to know what type of things that you are going to mitigate and have to handle that, you come down to the sort of component level. What is the expected lifetime of this type of components, and what components should we choose for different type of applications? And as was mentioned earlier, most of our power plants in nuclear power plants in Nordic are very old. We have now one new in TVO Finland, so that's fun, but most of them are old, so replacement strategies of these components are also of great importance to handle this long-term operation of the power plants in the best way. So we have a lot of projects in these 4 categories. Then, just to mention one of these projects that are a little bit more relevant than towards, for example, the digital twin, the project that we're going to speak about here is, we have done some projects which look into this. One of the problems that can happen is this subsynchronous oscillations, and this is a project that has been looking on combining them wind, and you also get this type of more power links included in the system. And what then happens? So this is something you can download the report and read more about if you want. But just some results here with what these HVDC links can generate, and as you see, there are different type of components and stages in this transformation, and some of these components, they give problem in the high frequency range, and that can affect some type of equipment. But then some of these components are more prone to give these subsynchronous resonances in this low frequency range. So this becomes very important then when you are going to design your system or building a big wind farm park, for example, close then to a nuclear power plant. Then you have to take this into consideration just to do this in a good and safe way. So some of the main conclusions from this project was not perhaps so surprising, but of course, the bigger this link and transformation station is, the bigger the risk is. The distance is very critical. If you're close, you're getting bigger. And also, if you have a weak grid as a whole, then of course this becomes a bigger effect. The good thing is that the overall risk can be quite well predicted at an early stage from the design parameters. You know what risk you are going to have. But also what's important, and sort of what I tried to show in the last picture, is that both the controller design and then what specific things you choose for your wind park concerning converters and things like that can have a very big impact on the risk. So this is an example on the type of things that we are looking into in GINO project, and this then of course this subsynchronous resonance has a problem because they come into the generator and cause the torsional, can affect the torsional vibrations and things like that. And if you're unlucky, you have a resonance between the electrical world and the mechanical world, and then you have a big problem. So hopefully next year perhaps Thomas Mer can come and talk, because this has also got some, with a new power upgrade on Forsmark 1, this is one of the things that you have to show to the authorities, that you can handle the dynamics with the grid and things like that to handle different types of cases. Then we could connect the mechanical and the electrical world. So that was my short introduction and example on what we are doing on the GINO project.
Yeah, it's very interesting. We discussed during lunch that in Germany we have this problem that the power is coming from the north to the south, and there are converters transferring from direct current back to alternative. And we are a group. We want to investigate this problem also, that the power plants are protected. And for this, we want to develop better models for the generator, for the shaft line, and also to include this in these grid programs to protect the power plants. And we think that up to frequencies 150 to 200 hertz should be included in this investigation. So it's not SSR, it's also, yes, up to 200. So there's a team, we are looking for proposals about it, but maybe we can work together also. So this is at the moment a poor German idea. because the problem occurs mainly in Germany, but I hear now it's maybe the same here.
Yeah, I think we have studied and also I think especially Vattenfall was quite early also developing models to calculate this. So there is both results recently in our, besides this report, we have some other reports also. So we can definitely have some exchange on it. That's just very good.
Good to know.